Okay, in this video we're going to take a look at the discriminant and then just apply it to a couple of these questions and see how we can do that. And that will also involve the use of some sign diagrams. So those are the skills that we'll look at today. All right, so the discriminant, we've seen our good old quadratic formula before, and we know that the discriminant is the thing that just sits underneath our square root there. Okay, so there she blows. Oh, yellow wasn't a good colour to choose, was it? Okay, and obviously if that is a positive value, we get two different solutions. So that's why down here we can say we will have two real distinct solutions. Graphically, that means it's going to cut the x-axis twice. Okay, and that happens when the discriminant is greater than 0. Obviously, when the discriminant equals 0, right, you'll have minus b plus 0, minus b take 0. You just get minus b. So that's why we will say that that's when it has one repeated real root, or equally, it's graphically, it touches the x-axis. And you get the gist now that when it's less than 0, that means the thing underneath the square root, the discriminant, is negative, and we can't take the square root or get a real answer for the square root of a negative value. So that's why we say no real roots. Right? There are imaginary roots, but we're going to stick with the real world here. And graphically, that means it does not touch the x-axis. Okay, so let's apply it now to some problems. And the first one we're going to look at is quite simple. It just says, by examining the discriminant, find the number of distinct solutions. All right, so first thing we will do is we'll just work out our discriminant. B squared minus 4ac. So in this case, our b is 8. So it's 8 squared minus 4 times our a value, that's a 1 there, and the c is 7. So we've got 64 minus 4 sevens are 28. Now, if this is a test question with non-calculator or, quite frankly, even calculator, I'm not going to bother working out what the actual answer is. I know straight away that this means 64 take 28 is greater than 0. Therefore, I'm going to have two real, distinct solutions. Okay, done and dusted. Let's have a look at the next one. So we're going to do exactly the same thing. So b squared minus 4ac, probably going to run out of room, so let's go underneath. So that's going to equal, once again, 64 minus 4 times 3 times 7. So I've got 64 minus 12 times 7, right, which is 84. And clearly, yes, that's minus 20, but all I have to do is say it's less than 0. Right, therefore, no real solutions. Okay, roots, solutions, zeros, etc., etc. None of them are real. And last but not least, so b squared minus 4ac, that's going to equal minus 1 squared. Now, just a little bit of a warning. I think if you use your calculator incorrectly, your calculator could tell you that minus 1 squared is minus 1, right? So incorrect use of the calculator is to say minus 1 squared, right? And that gives you minus 1, which is wrong. Technically, you have to make sure, not technically, but you have to make sure you pop it in brackets, okay? Ideally, you wouldn't actually even need to use a calculator for this. So minus 1 squared, take 4 times a, which is 10, and c, which is minus 3. So negative times a negative is a positive. We've got 1 plus 120. That's greater than 0. Once again, we're back to two real distinct solutions. If we did an example and it equaled 0, obviously we would then say one repeated solution, but I don't think we have to go through that. Let's take it up a notch to the next level of questions. So find the value of m for which each of the following equations has no solution, one solution, two solution. So we'll start with the first one, a, and we're going to say, right, what is, let's first work out b squared minus 4ac. If you can't do anything else, at least do that. So that comes back to, well then, what's our a, what's our b? So we've got a 1 there, that's our a. We've got our b, which is your whole coefficient of x, so that's minus 4m, and your c is 20. Okay, so let's pop these in. So it's going to be minus 4m squared. Right, that's our b squared, minus 4 times our a value is 1 and our c value is 20. So 6m squared, because 4m times 4m is 16m squared. And what's that? Minus 80. So now we're going to come down to how does this apply to when we've got no solution, one solution, and two solution. So the easiest one is to work out the one solution first, because it's going to have one solution. And by the way, when you're doing this, make sure that you say that. So one solution, okay, when the discriminant equals 0. In other words, when 16m squared take 80 equals 0, so 16m squared, pop the 80 on the other side. You know what's going on here. We're going to get rid of the times 16 by dividing, and we'll then get rid of the square root. I better write that. We'll get rid of the squared by square rooting. And please again remember, when we square root, we get a plus or a minus answer. So that we will have one solution. In other words, the discriminant will equal 0 when m equals plus or minus root 5. But how is that going to help us work out when it has no solution? So for part 1, no solution, tell the marker that you know what's going on, so at least you'll write the discriminant is less than 0. Okay, what we want to do here is we're going to make use of a thing called a sign diagram. So we will draw, it's basically a number line. Okay, so we pop minus root 5 here because that's the minus side, and then we've got root 5. Now I'm going to pick a number somewhere along this side here and place it back into my discriminant. So what's a number that's bigger, right? Bigger than root 5. And to keep my life simple, I'm going to choose, well, what if m was 10? And I'm going to replace that into 16m squared take 80. So that would be 16. 10 squared is 100. Take 80. And what I'm interested in is it positive or is it negative? And clearly 1,600 minus 80, that's going to be a positive value. So I will pop positive value here. Now I'm going to do the same for a number in between minus root 5 and root 5. And the easiest one to pick, of course, would be 0. And I'm going to replace that back into 16m squared take 80. So what's 16 times 0? That's 0. Take 80, that's a negative number. So that means in between here, that's a negative. Now we're going to pick a number, right, along here. What's a number that's less than, right, more negative than minus root 5? Again, you could choose minus 100, minus 1,000. I'm going to, you guessed it, I'm going to choose minus 10. Okay, and I'm going to pop that back into 16m squared take 80, right, always. So it's always good that you have found your discriminant here because we keep going back to it. Now be careful, remember when we square a negative, so that's minus 10 all squared. Okay, you're going to have 16 times 100 take 80, and that's going to be a way positive number. Okay, so what this sign diagram tells us is that when we've got values for m that are in between root 5 and minus root 5, that's when the discriminant will be negative. Okay, so I'm going to write that down. I'm going to say when m is less than root 5 and when it is greater than negative root 5. Okay, so that's how I say it's in between minus root 5 and root 5. So obviously, the only thing now that is left is, well, when does it have two real distinct solutions? And that will be when your discriminant is greater than 0. And we've already done all the hard work here, right? The only thing that's left is that's going to be when m is greater than root 5 and when m is less than minus root 5. So remember, first thing you want to do is actually find your discriminant, find the values that make it equal to 0, and then we're going to do a sign diagram. So that was a bit of new information. Let's do B. Okay, so this is B, but we're doing exactly the same question, okay? So we still want to find when does it have no solution, when does it have one solution, and when does it have two distinct solutions, two real distinct. So we're going to do part B, which I have now written down over here. So the first thing that we are going to do is actually find the discriminant. So here we go, b squared minus 4ac. Remember from last time, your b value is the coefficient of x, so it's that minus 3m. So we're going to go minus 3m squared, okay, minus 4 times a. My a value is m, and my c value is 3. Okay, so we've just worked that out and simplified that. My pen's starting to give a bit of trouble, so hopefully it holds out. All right, so even though the question is saying, when is it no solution, one solution, two solution, the easiest one and the handiest one to work out first is when it has, so part 2, when it has one repeated solution. All right, remember another way to say that is if it was touching the x-axis. So one repeated, that means we're going to now say we are trying to solve, or we say what you understand, the discriminant equals 0. So what we are solving now is 9m squared take 12m equals 0. So we're taking our minds back now to how do we solve this? Remember, you have to look for a common factor. The highest common factor, what's the biggest number that goes into 9 and 12? In this case, that's a 3. And of course, m is common to both. So we pull that out. 3 times 3 gives me the 9. M times m gives me 9 squared. Take 4. Okay, so we've got m is 0. And we're solving 3m take 4 equals 0. So that is 4 over 3. So those are our solutions for when it has a repeated root. Now we're going to go back to the first one and say, okay, when it has no solution, that's when the discriminant is less than 0. So in comes our sign diagram. Okay, 0 will be here. 4/3 is clearly greater than 0. We're going to pick a number beyond 4/3. I'm going to go with 10. Okay, and I'm going to pop that into my equation. So 3m, because now look what happens. 3m take 4. Now what's 3 times 10? I know it's 30, but guess what? I don't even care. All I care about is that it's positive. What's 3 times 10? 30 take 4. That is also positive. So what happens when you have a positive times a positive? We get a positive answer. Now I'm going to, so I better put that was 10. What happens? We want to choose a number between 0 and 4/3. So I think 1 would be a great one to choose. So once again, I'm looking at 3m. 3m take 4. If you want to, you can actually just sub it back in here and see, do I get a positive number or a negative number? I just do this. I find it easy. So 3 times 1 is positive. 3 times 1 is 3 take 4. So 3 take 4 is a negative answer. Positive and a negative. That gives me a negative answer there. Now we pick a number beyond less than 0. Minus 10. And I'm going to pop it into 3m. Okay. Oops, sorry. Jumped a bit there. 3m times 3m take 4. Okay, we're popping in minus 10. What's 3 times minus 10? That's a negative answer. 3 times minus 10 is minus 30 take 4. That's also a negative answer. So a negative times a negative is positive. So therefore, when is it going to be less than 0? When it's in between 0 and 4/3. So when m is less than 4/3 and when it's greater than 0. And the last one then, as we did before, we can just solve that without having to do any calculations because it's in this section here and this section here. So we say that mathematically by saying m is greater than 4/3 and m is less than 0. All right. Oops, sorry. What I'll do is we'll do the other ones here and I'll pop those on as notes and put them in the OneNote. But try and have a go at them without looking at the solutions first. Let's just get you started though. So for C, what's your A value going to be? It will be 5. Your B value will be minus 5m. And your C value will be minus m. For D, they're being very nice. A is going to be 1, B will be 4m, and C, a little bit trickier, but it's minus 4, m take 2. Gone my pen. Actually, I might just do C. No, I won't.